अरे मिडिल voice is listening. Okay.
Yes, good morning, everyone. Mute yourself. Mute yourself. Malapur branch. Malapur branch. Please mute yourself. Good morning to all, and now we are going to discuss about our vector concept. And yesterday we are concluded about that how many types of vectors are there. Yes, different types of vectors we are considered. What is the properties of the vectors also we are considered here yesterday. Now we are going to discuss the remaining concepts. Whatever the vectors are there based on the angle, how we classify the vectors. Yeah. As yesterday we consider up to space vector, one-dimensional vector, two-dimensional vector, the space vector. Then after, what is the angle between any two vectors? That is only we are going to discuss now. Yes, the angle between the two vectors. One vector, two direction we are consider, but between the two vectors, how we consider the angle here? That is only now we are going to discuss. Angle between two vectors. Angle between two vectors. Here there is a two vectors are there. One is the A bar vector and another one is the B bar vector. It is there. A bar and other the B bar vector. It is there. And here, how to find out the angle between these two vectors? Yes, and here there is we are taken a one. Yes, we are taken the vectors are like that. Yes, suppose there is two vectors are there. We are followed by the one head to the another head. Okay, clear or not? As well as one head is connected with another tail. Okay, what is the angle between the things? Okay, now there is a what we are taking the angle between the vectors are like this. Means what we are taking two vectors from one particular point. Okay, now and as well as what is the angle between the two things? Otherwise, we are taken in this particular format also. Okay, clear or not? Yes, in the two ways we are considered. Yes, sure there is a head coincide or the tail coincide. At that time only there is they are considered. Yes, if head is a coincide or a tail is a coincide, yes, internal angle is the angle between the two vectors. Yes, if the head coincide with the tail, then external angle is the angle between two vectors. Okay, yes, that is only we are considering. Okay, clear or not, all the students? There is a what? They have taken head or otherwise. This is the head of the vector, you know well. This is the coincide with the tail of the vector. Okay, clear or not? At that time, there will be get what is the angle between that. Suppose when there is a head and head is a coincide, yes, what the things are will get for us. And head and the tail is a coincide, what the angle may get for us. Okay, in this way we are considered. Yes, but when there is we consider the head and the tail is a coincide. Head and tail is a coincide. External angle. Okay, we are taken, and but when there is a two tails are coincide, that will be taken as the what internal angles we are considered. Yes, and in this way there is we are taken the angles between the yes two vectors. I hope you got it here. There is a when there is a two vectors given a bar and the b bar. Okay, now what is the angle between the a bar and b bar and c bar and d bar? We should make connection of the two vectors. Yes, or otherwise it will make called parallel. Okay, now yes, like so many. It is the parallel with one another. Okay, clear or not? There is a no angle between the one vector and another vector when they are in this particular form. Okay, when they are not connected. But when there is a one is a touch with another one, either may head or may tails are connected. Okay, now the tails connected internal angle may get. Okay, there is a when we are connected, there is a one tail, another head. We get the external angle. Okay, clear or not? Externally the angle may get for us. Yes, that is only we are considering here. Yes, and next Cartesian coordinates. Next component is what? Cartesian coordinates of our yes vectors. Cartesian coordinate. What is the Cartesian coordinate? Okay, now how do we consider Cartesian coordinate? Yes, and here, in order to describe the motion of the object, we must specify the position related to the observer. One of the most convenient coordinate system is the Cartesian coordinate system. It's a consists of a three mutually perpendicular axes designated x-axis, y-axis, and z-axis. Location of any point is specified by these three coordinates. Okay, that is only called a Cartesian coordinates. Okay, once again I repeat it here. Suppose we want to find out the position of any object. Without finding the position for a physical quantity, there is no meaning. Okay, clear or not? All the students. I hope you got it here. When we are take a physical quantity, at that time only that the physical quantity contain one particular significance. Otherwise, there is no significance for that physical quantity. Got it? Or? Yes, I hope there is you understood. There is no physical quantity is considered without a position. How we are specified the position by using the vectors, by using the Cartesian coordinates only. How we consider the Cartesian coordinates? Actually, you know very well, there is a three axes are there. One particular point is at this particular position. We are taken the distance from the our axis R or G. Okay, clear or not? Yes, we are taken about the positions. Yes, first we are taken from the what RG. Okay, now the origin is called the 0, 0, 0 axis. This is the what actually x component. This is the what is that y component. This is the what it is z component. Means what? This point, whatever the position we have taken, it will be how much far distance from x axis. With respect to axis, what is the position? With respect to y-axis, what is its position? With respect to z-axis, what is its position? Suppose I am taking a point here, and when I am right here, x comma y comma z means yes, it's somewhat distance made from the x-axis like this. From the distance made from the y-axis are like this. From what distance is the made from the z-axis are like that. Okay, clear or not? Suppose I am taking there is a one point is there 1 comma 1 comma 1 means what? Everywhere it is a 1 unit distance from the with respect to x-axis, with respect to y-axis, with respect to z-axis. Got it? This is only called as the Cartesian coordinate system. Yes, I hope you got it here. Yes. Here, whatever the Cartesian coordinate system, every time it should not be positive only. Sometimes negative components are also may get for us. Got it or not? There is a different components are may get for us. Sometimes there is a negative components are also may get. How? There is suppose I have taken the point is on x-axis, this particular position. Okay, now at that time there is a what it is a minus one somewhat. A component is a become what a minus x, and it is a positive y-axis. Okay, now the z-axis may be positive only. They are right like this. Only simply there is a whatever the coordinate system is there x comma y comma z. Okay, now with respect to that axis, what is the position of our particular point or a particular physical quantity? Got it? That is only we are considered here. That particular point we are where we are designated. Okay, where we are located with respect to x-axis, with respect to y-axis, with respect to z-axis. That component is only become what Cartesian coordinate system. Okay, either may it is a 1 comma 1 or it is a sometimes it may 0 also may get 1 comma 0. Means what there is a no okay na yes coordinate of y-axis with respect to y-axis there is a no distance, no component. Okay, clear or not? Any one of the 0 there is a no component with respect to the concerned axis. We are consider that. Okay, suppose you take on a board. The board is not a 3-dimensional. It is our 2-dimensional. Okay, x-axis and the y-axis. Okay, now yes, we want to take one body on the x-axis and y-axis. There is no meaning of what y-axis, z-axis 0. Suppose you take one body on a room or in a room. Okay, in a room. Okay, your position in your bench compulsory require the yes x comma y comma z components. 3 components are required. By using one component, it is not possible to yes describe the body position. Got it? That is only called what Cartesian coordinates. The Cartesian coordinates are give the position for our vector. Okay, clear or not? With respect to at where it is, with respect to yes y-axis where it is, with respect to z-axis where it is, with respect to x-axis where it is. Got it? This is only about the Cartesian coordinate system. Yes, next after this. Orthogonal vector. Next component is the orthogonal vector. Orthogonal vector. Which one is called orthogonal vector? Okay, that is what we are considering. If the angle between any two vectors is 90 degrees, those vectors are called orthogonal vectors. Simply, there is a what when we take any two vectors, the vectors are contain a 90 degrees between them. Okay, that is only called what orthogonal vectors. Suppose there is I am taking these are the two vectors. Okay, clear or not? Yes, there is a what is the angle between these two things? 90 degrees. Suppose you take a north and as well as the east. What is the angle between these two vectors? 90 degrees. That's why it is called orthogonal vector. The perpendicular vectors are orthogonal vectors. Means what? The angle between the two vectors are become 90 degrees. Got it? Yes, this is one more type of a vector. Next come to here after this orthogonal vectors. Yes, we are taking this as what actually orthogonal unit vector. Orthogonal unit vector. Which one is called orthogonal unit vector? Okay, clear or not? Orthogonal vectors are nothing but 90 degrees. Orthogonal unit vectors are nothing but the unit vectors along x-axis, y-axis and z-axis are joined by I, J, and K. Yes, these are whatever the caps are there, crown or a cap, whatever there, that represents a what? Orthogonal vector. Suppose, okay, the vector is along the axis. Okay, along the axis, x-axis. Okay, that vector is become what actually is orthogonal vector, and it should be contain unit magnitude. How you know? Then it is taken as what I got I is equal to taken as x bar. Okay, by mod x. X bar by mod x. Okay, clear or not? That is indicates about actually that is indicate x bar is equal to taken as x bar is equal to taken as x I bar. Okay, this is it's equal to which thing? Orthogonal unit vector. Understood all of you? Yes, the vectors along the axis is one. Yes, the vectors along the coordinate axis, not the whatever may be axis here. Coordinate axis. How many are there totally? May there is a 6 components may get for us. Okay, not only 3 components. Xi minus x. S, xj, yj. Okay, minus yj. Okay, like for every axis, there is a one components we get. Yes, along the positive axis, along the negative axis. Okay, that is only called as orthogonal unit vector. Got it or not? This I bar, j bar, k bar. They are what actually unit vectors along the coordinate axis. That is only called what? Orthogonal unit vectors. Got it or not? Yes, suppose they give an example for us. What is that? A vector 4 units along the positive x-axis. Then x bar is equal to become what? 4i. Okay, a vector of I magnitude of 5 along the negative y-axis, x-axis. That will become 5i. Okay, got it or not? Yes, now there is it is only called orthogonal vectors. I hope you understood. There is a magnitude is somewhat here 5, but it is along x-axis. The orthogonal vector it will be written as what? 5i bar. Got it or not? That is only called as orthogonal vectors. Okay, now I bar is what here then? I bar internally the meaning of I bar is x bar along the x bar, along the x axis and the mod x. Okay, we have taken a mod x. Mod is nothing but magnitude of the vector component along the x component, along the x axis. Okay, the coordinate axis we have written now. The coordinate component is written, it is on the x axis. From what distance it will be made? Okay, that will become what actually as with respect to y axis. There is no components here. Okay, there is along x axis only it will be there. Okay, along the y axis it is 0. Okay, along the z axis it is 0. Got it? Yes, and here, but it will be contain the component along the coordinate axis only, and that is why that magnitude and organized along the axis. When we are taken ratio, we'll get one vector. That unit vector is only called as orthogonal unit vector. Got it? Yeah. Then how to find out the magnitude of vector when they given the vector in the form of a coordinate Cartesian coordinate based. Yes, how we are represent the Cartesian coordinate based vector like this. A is there now. It will be taken as AXI, AYJ plus AZK. This AX indicate the component of x-axis. AY indicate the component or the coordination point of y-axis. AZ is the indicates the coordinate component of the yes, like this. X comma y comma z they become what actually ax comma ay comma az, and this I bar, j bar, k bar are become what unit vectors along the x-axis, y-axis, z-axis respectively. Got it or not? These are only about orthogonal vector, and we represent the vectors are like this. We want to find out the modulus of the vector a bar. This is indicate the magnitude. Yes, you have to take this formula: ax square plus ay square plus az square. Got it? under root of ax square plus ay square plus az square. That is only indicate the magnitude of the vectors. Got it or not? Yes, I hope you got it here. Yes, this is only indicate the magnitude of the vector. Got it? Yeah. Now there is, we have to take here. Yes, suppose one vector a bar is equal to there. A bar is equal to taken as 4i minus 3j bar. Yes, and here mod a bar is equal to taken as under root of 4 square s plus minus of 3 whole square. This is only become the modulus of the vector. There is a no z component here, only x component and other y component we are taking. This is become what, a 60 minus of 3 whole square become plus 9. Okay, clear or not? Minus 3 into minus 3, that is become what, minus into minus plus 3 into 3 9. In this mode I am written. Yes, then it is a become what, under root of 25. There is a what it is become, a bar mod is equal to modulus of a bar is equal to taken as 5. Okay, in this way only we are calculate the moduluses. With this, all the types of vectors they are completed. Once look at all the whatever the types of vectors we have discussed in the previously, there is a whatever the 2 to 3 classes we have taken now. In this one, there is only just we are discuss about what is the types of vectors and how to find out the angle between them. Okay, what is required, what is in coordinates are required, and orthogonal unit vectors are required, and the modulus of the vector is also required. These all the things are only lastly provide for us these vectors. Okay, clear? Yes, this is only about the components of our total. Yes, requirement to perform the mathematical applications on our vectors. Got it? Yes, how to find out the angle between them, you know, and what is the direction, you know, and what is the vectors. Now we are going with the problems in the lecture 3. That is the practice sheet is the taken 3. Practice sheet 3. All the students, please note down the answers. Yeah. Yes, first one. If head coincide with the tail, then dash angle is the angle between the two vectors. Okay, clear? Yes, the first one conceptual questions here. Okay, now in that one, if heads coincide with the tails, then dash angle is the angle between the two vectors. Heads are coincide with the tails, external angle is the angle between the two vectors. Okay, clear or not, all the students? When the heads are coincide with the tails, there is a what will be get? Yes, external angle is the angle between the two vectors. Okay, first one is the what? Head is coincide with the tail. Okay, what will we get for us? External angle naked. Okay, not internal angle. We are considered. There is an external angle may be considered. Yes, which type of angle? There is a external angle may consider. First one is external. Second, all the vector whose initial points are same. Such vectors are called what? Such vectors. You know very well. The vectors are contain the same vectors are initial point. They started from the same initial points. That vectors are called co-initial vectors. What it is called? Co-initial vectors. Yes. The example is you take like that. These all the vectors are called co-initial vectors. Got it? And next, the third point, third question, what is there here? If the two vectors have the same magnitude and direction, they are said to be equal vectors. These are said to be what? Equal vectors. Here we are taking the vectors of this form, that is called what? Equal vectors. In case they are contain a field 2 meters, somewhat 2 meters, and the direction is also same, that vectors are called what? Equal vectors. Next, fourth one, define cocurrent vectors, define unit vector and null vector. You know very well. There is a whatever the cocurrent vectors are there. Yes, and here that is the initial points are started from same. These are the vectors are called, yes, cocurrent vectors are initial vector, co-initial vectors. Got it? And next, the fifth point, whatever there is about unit vectors are nothing but what? There is a unit vector that taken as somewhat a cap, that is a bar by mod a. That is only called as unit vector. The vector is only called as unit vector or null vectors. Null vectors are nothing but what? Opposite in direction, with the same magnitude. The resultant one is become what? Null vector, zero bar. Okay, clear or not? This is only called a zero bar. These are the conceptual question answers. Please note down the conceptual question answers. Please note down. Next, we are doing the level 1 questions. Level 1 question. Yes, next come to here, level 1 here. A vector having magnitude only 1 is called. Got it or not? The vector which are contain magnitude only 1 is called as what? Yes, that is called unit vector. You know very well when you are taken is a A bar. Okay, the A bar is a taken as somewhat a capital A bar by mod A. When you take it is called what? It is called a unit vector. The vector is not a contain more than one magnitude. It is a contain only the magnitude is a one. Suppose you take here I, S and as well as the J and as well as the K. This is the contain amount. What is the magnitude of it? It is a become actually the magnitude is a become. Yes, one shaky. What happened? There is a I bar plus J bar plus K bar. Yes, 1 square plus 1 square plus 1 square. Okay, now in this way we have to consider that is a become. Okay, that is a become what actually as unit vector. The magnitude is a become should be 1. That is become as the unit vector. Got it? Yes. Suppose only simply take I bar. What is the magnitude of it? Is 1 only. Then it will become what? Unit vector along the x-axis. Yes, that is why the answer is the become what? The answer is first one is for it is a unit vector. C. Next, second answer. Position vector is a vector that defines vector. Actually, the position vector is a vector that defines the vector. What is the position of the vector only? Yes, and means what here? There is a where it will be actually. Got it or not? Yes, and in a coordinate system where that our particle, our vector is there, that is indicate the position vector. Okay, it indicates not the direction, nor the magnitude, nor the angle. Just it is indicate the what? Position only. Okay, now S x-axis, y-axis, and as well as the z-axis. Where it is. Next, a vector whose magnitude is a 0. It is called null vector. You know very well. It is called what? Null vector. The answer is become D. Okay, now already we have discussed it so many times about the types of vectors. If the vectors have same magnitude and are parallel to each other, yes, then the vectors are called yes like vectors. Okay, now yes, and as well as the what unlike vectors are nothing but they are contained and opposite directions. When they are contained, yes, same okay in a direction, they are become what actually they are become what equal vectors. Okay, clear or not? Same magnitude and direction. Okay, na? And this is the called what actually equal vectors. That is the become what D. Fourth answer is again D only. Yes. And next, if any vector possesses say components along all three x, y, and z, such vectors are called space vectors. You know very well. Yes, space vectors. Why it is called a space vector? That is what a component is a contain in all x-axis, y-axis, and as well as the z-axis. Like that, xi plus yj plus zj. This is the called yes. This is the called what? This is the called as what it is? Space vector. In case only two components are there, it is called a 2D vector, a two-dimensional vector. Otherwise, it is a contain only one component. It is called axial vector or a one-dimensional vectors. Got it? Or? These are the level 1 answers. Please note down. Next, we are going for the level 2. The level 2. Which of the following vector represent the co-current vectors here? Okay, clear or not, all the students? There is a given. The options are different. Options are given. Yes, these are the co-current vectors. No. What is the meaning of the co-current vectors? The meaning of the co-current vectors are nothing but the starting from single point only. The A is not an answer. Next, you have to take a B. Option B. What the option B? Yeah, exactly. There is a what? There is a one point is there. This is the A bar and this is the B bar. Somewhat a C bar. Another one it is a what actually they are taken as a B bar. They are moving from what a single point. That is why it is a what a co-current vector or initial vectors. And when you are taken a this vector, yes, this is also starting from a single point only, but they are called orthogonal vectors. Okay, not a co-current, exactly co-current. Yes, but they are also starting from a same point only, but they are contain 90 degrees. It is not a multi-answer question. In case the multi-answer question, this will also become the a co-current vector only. There is a no mentioned about there is a angles, but the starting from one particular point, whatever may be the direction, whatever may be the magnitude, the starting from one particular point only. Yes, A and as well as the B. Okay, now yes are wrong answers. There is a and C and D are wrong answers. But somewhat times A and as well as C is also taken as C is orthogonal vector. Okay, C is orthogonal, but it starts from the single point only now. That is next. After this, there is consider one more thing. Which of the following vector represent anti-parallel vectors? Anti-parallel vectors. There is a what anti-parallel means. There is you have to should take yes, the directions are different here. There is a two are anti-parallel. Whatever may be the magnitude, we not required any magnitude component here. Only just direction we have considered. That's the answer is become D. Answer is become D. Why? Because the both are anti-parallel only. Okay, now they are contain what directions are not same. Okay, now one is a anti-parallel to the another one. One is in this direction, another one is in this direction. Automatically, the become anti-parallel. Yes. Next, eighth question. Sorry, sixth one, seventh, eighth, ninth. Next after this, we are going with the 10th one. It is the 10th question. A vector of zero magnitude is called. A vector of zero magnitude is called what actually? Yes, this is called equal vectors or a unit vectors or a null vector or a co-current. It is a called what? Null vector. Which are contain a zero magnitude. It is a called what? Null vector. The magnitude is zero, but the direction is somewhat undefinable. It is not definable here. Undefinable. Direction is not become zero. Direction is not determined by us. Okay, that is only called as zero vector. Got it or not? Yes, or a null vector it is. Yes. I hope you got it here. Yeah. Next, after this, ninth question. Any vector of a non-zero magnitude is called a proper vector. Okay. Yes. When there is a vector is contain a non-zero, that is also called as a proper vector. Yes. You have already the components about this. Yes. A null vector below the null vector one second. In case the magnitude is yes, not here zero. That is a become called. That is called as what actually proper vector. There is any vector of a non-zero magnitude is called as a proper vector. Okay, got it? It is called a proper vector. Answer is become what actually? Yes, B. Identify the scalar quantity. Again, here they given. Yes, you know very well. The force, acceleration, displacement. They are the vectors working scalar quantity. Yes, please note down these are answers. Easy things only. Whatever the pictures are given, once check with whatever our regular synopsis they given. Yes, first you read the synopsis for solving these all the practice things. Okay, now yes, whatever 17 things are given in a synopsis, like whatever the types of vectors, how to find out angles, and what is orthogonal unit vector, and what is the Cartesian coordinate system, what is the null vector, what is the terminal vectors, like this. There is a 17 components are there. How to read the 17 components, and these are the level 1 and level 2 answers. Tomorrow we'll go with the level 3 and as well as IIT and advanced practice. Okay. Thank you, students.